Dear students, now let us discuss one very important problem and the concept related with your mathematics. That is the line integral of a line, line integral of a vector function. Okay, now we should understand that what is a line integral of a vector function. So in your mathematics, so majorly we are going to study about a line integral and surface integral and volume integral. So when you heard a word line integral, which means we are going to integrate only one time. If you heard the word surface integral, which means we are going to integrate the given function twice. If you heard the word the volume integral, which means we are going to integrate the given function thrice. That is a difference. So since it is a line integral, it is a linear. That means only one time we are going to integrate. If it is a surface integral, we are going to integrate twice. Since surface is nothing but two-dimensional, and when it is a volume integral, volume is a three-dimensional, therefore we are going to integrate three times. That is a difference, right? So now, to understand the line integral of a vector function, let us consider a vector function here. Let vector A be the vector function, let it be vector function in the region R. Here the capital R indicates some region. So let us consider this is a region. In this region, I am going to consider a vector function, that is capital A. Capital A be the vector function in R in a three-dimensional space. In a three-dimensional space. Okay. So three-dimensional space, which means what? So it is bounded with three axes, that is x-axis, y-axis and z-axis. So that's why this A vector is a function of x variable, y variable and z variable. Understand once again, capital A be the vector function in R, defined or explained in a three-dimensional space. And now let C be a, let us see capital C. This capital C indicates the curve. Let capital C be a curve defined in the same region. Defined in the same region. That means defined in the region R. Okay. So here, mind it, capital A be the vector function and CB is just nothing but a curve where we are going to define a vector function. So now we have to define the vector equation. Vector equation. This is very important. Very important. Vector equation is, this is very important. So to write down the vector equation, we have to construct a three-dimensional space here. Just have a look on this. Have a look on this. Okay, now I have taken this one. I have taken this one. This is an x-axis. This is an y-axis. This is a z-axis. Here I am going to consider a curve here. Right? Got my point. So in this curve, initial point is taken as A and the final point is taken as B. So this let capital A and capital B be the initial point and final points of the curve. Through that, I can draw here something here. This is T is equal to A. Here I am going to write something here is equal to T is equal to B. That means the T is, the parameter T is varies from A to B. So that A is a lower limit and B be the upper limit. Keep in mind, okay, let A and B. So vector equation, right now we have to write the vector equation here. So this vector is in a three-dimensional space. Therefore, we want the x coordinate, y coordinate and z coordinate. Therefore, the vector equation is denoted by R vector. If this R vector is equal to x into I cap plus y into j cap plus z into k cap. This is very important. The vector equation is taken as R vector is equal to xi plus yj plus zk. So here what I am going to write, let A and B, look at that, A and B are the 2 points on the curve through a t is equal to a and t is equal to b. I am going to write here. Let a and b are the 2 points on the curve, 2 points on the curve defined from so t is equal to a and t is equal to b. So this is very, very important. Here t is equal to a is called as lower limit and t is equal to b is called as upper limit, which means the value of t is varies from a to b. This is the concept. Now what to prove here, sir? So let a and b are the 2 points on the same curve defined from t is equal to a and t is equal to b. On this curve, I am going to take a point here. This point is a 3-dimensional. Therefore, this point can be taken as x comma y comma z. This is a variable point. At this point, I am going to write a tangent here. Along this tangent, we are defining dr vector divided by dt vector. Have a look on this. Right. So here, x comma y comma z be a variable point. That means variable point on the curve, on the same curve. Got my point? So x comma y comma z be the variable point on the curve, and dr by dt is along the tangent drawn to the curve at the point P of x comma y comma z. Here we are taking a point here, that is a point P. At that point, we are drawing a tangent here. Along this tangent, we are defining dr divided by dt. Because why it is dt? Because t is a parameter. All the values of the function depends upon the parameter t only. Why we call it as t is a parameter? I already said that any function value which depends on some physical quantity, that quantity become a parameter. Here, all the values are depends upon the values of t. Therefore, t become the parameter. Okay, now the very important thing here. Sir, what is that, sir? Here x comma y comma z be a variable point on the curve, that is okay. Therefore, here x comma y comma z represented in t. Sorry, first the point, the vector a is represented by have a look on this, represented by x comma y comma z. And the point x comma y comma z are the functions of, this is very, very important, are the functions of variable t. This is, keep in mind, the vector function a vector is given in terms of the variable x comma y comma z. Either it is x, y, z or association of all these things. But strictly the x coordinate, y coordinate and z coordinate, they are given in terms of t. Therefore, now what is the required thing here? What is the line integral here? What is the line integral? So for now here we have a vector, here r vector. If you differentiate r vector, you will get dr. Got my point? Therefore have a look on this. A vector dot dr vector is a scalar function. Is a scalar. Why it is a scalar? Because dot product is always a scalar quantity. A vector into dr vector is a scalar quantity. Therefore, integration of, have a look on this, integration of scalar function, SF I am going to write, integration of a scalar function a into dr between t is equal to a and t is equal to b is called line integral of a scalar function. Line integral of a scalar function. Understand this. This is very, very important. This is very, very important. So, if somebody asking that, what do you mean by line integral of a scalar function? So, integration of a scalar function a vector into dot. This is not into, it is a dot. A vector dot dr vector between t is equal to a and t is equal to b is called line integral of a scalar function. Already we know that a dot dr is always a scalar function. Now we have to conclude that. So what to conclude here, sir? This is very, very important. Therefore, line integral denoted and defined as how we are going to write? So integration C. This is a C. C is nothing but a curve. Why we are taken curve here? On this curve only we are defining a vector function. Therefore, integral over a C a vector dot dr vector, we call it as line integral. This is given by integral from this curve is defined from t is equal to a to t is equal to b, a to b, a vector dot dr vector divided by dt vector into dt. Again look at that, dt get cancelled, you will get a dot dr vector. This is what. Keep in mind, the line integral over a curve C is given by integral over C a dot dr, which is given by integral from a to b, a vector dot dr by dt into dt. That's it. Now here very, very important factor is work done. To find out the work done, the very important thing is to find out the work done. So in order to make any work done, we need a force, right? Let F be the, if I take capital F or small f, F be the force acting on the body, in the curve C, then work done is given by W is equal to, here W indicates work done, that is equal to integral in a closed interval, in a curve. So instead of A we can replace as F vector dot dr vector. So this is a formula to find out the work done. Understand? Once again understand. Here A vector is a vector function, R vector is a vector equation. Then a vector dot dr by dt be a scalar function. Therefore, integration of a scalar function a vector dot dr by dt from a to b is called as line integral of a scalar function in a curve C. So, if F vector is a work done, force applied on a body in the curve C, then the work done is given by W is equal to integral over a curve C F dot dr. Okay, now let us discuss few problems related with this line integral. Okay, so what are the basic things to do the problems here? What are the basic things? What are the steps involved here? I am going to write some of the steps which are associated to find out the work done on a line integral of some functions, right? So now let us understand. The first step is, keep in mind, the first step is write the vector equation. What is that, sir? Write the vector equation. I already explained that. The vector equation is R vector is equal to xi vector plus yj vector plus zk vector. Got my point? Write the vector equation. R vector is equal to xi plus yj plus zk. So then replace the value of xyz. Replace the value of x comma y comma z in terms of t. I already said that in terms of t. Then what is the second function is find out dr by dt using r vector. If you differentiate r vector with respect to t, you will get dr by dt. What is the next procedure? Write down vector function. So if they are given in terms of A, write down A, or if they are given in terms of F, write down F. That's my point, right? Then the next step is find out A vector dot dr by dt, or instead of A we can use F vector dot dr by dt. These are the procedure. Next, what to do, sir? Next, apply the line integral. Line integral. What is the line integral here? That line integral is integral in a curve C vector A into dr. A dot dr. This is given by integral from A to B. We should understand the lower limit and upper limit. This can be written as A vector dot dr by dt into dt. So that's why here we are going to calculate A dot dr by dt. So first understand R vector, replace x, y, z in terms of t, then find out dr by dt using the vector function, write down the vector function A function or F function, then find out the dot product of A and dr by dt or F and dr by dt, then consider the line integral formula A dot dr, or you can use this one also, C F dot dr. Then what happens here? F dot here, integral from A to B. It is very simple. Instead of A, we have taken force here. That's it. That is F vector dot dr by dt into dt. That's it. Got my point? So these are the steps involved while working the problems associated with line integral. Right? Now let us understand and do some very beautiful problems associated with this line integral. Okay? Let us consider a beautiful problem here. Let us consider a beautiful problem. So what is the problem, sir, here? What is the problem? If F vector is equal to, they are given force, right? If F vector is equal to, if you understand one problem, it is very easy to handle other problems also. If F vector is equal to xy into I plus yz into j plus zx into k, where I, j, k are the components along x axis, y axis and z axis. Evaluate is the problem. Evaluate integral over C F vector dot dr vector, where C be the curve, right? Where C be the curve represented by x is equal to t. Understand this? X is equal to t, y is equal to t square, z is equal to t cube, and t is greater than or equal to -1, less than or equal to +1. This is the problem. So dear children, understand this problem. So F vector, they are given xy into I plus yz into j plus zx into k. Evaluate the line integral. Understand this? Here we have only one integral symbol, therefore it is a line integral f dot dr, where c be the curve represented by x is equal to t, y is equal to t square, z is equal to t cube. I already said that the variable x, y, z given in terms of t only, because t is a parameter. Now understand the steps involved here. First, to write down the vector function, right? So vector equation. What is vector equation? R vector, right? So let R vector, as you know that R vector is equal to xi plus yj plus zk, since it is a 3-dimensional. If it is a 2-dimensional, we can write xi plus yj only. Since it is 3-dimensional, we have all the coordinates xi plus yj plus zk. Now, what is the next? We have to replace the value of xyz in terms of t. Therefore, R vector is equal to, understand what is x here? Ti plus what is y there? Y is t square into j plus what is z here? Z is t cube into k. So after getting this, what is the next step? The next step is to find out dr by dt, is it? So dr vector divided by dt vector. So just differentiate as usual. In derivative of t with respect to t is 1 into I plus t square, it is nothing but 2t into j. T cube is what? 3t square into what? K. This is dr by dt. After getting dr by dt, write down the f function. Why f function? We want to know that f dot dr by dt. F they are given xy into I plus yz into j plus zx into k. Now slowly replace the value of x, y, z. They are given. What is x here? X is t, y is t square into I plus y is what? T square. Z is t cube into j plus z. What is z here? Z is t cube. X is what here? T into what? K. Simplify this. This becomes t cube I plus t power 5. T square into t cube. When bases are same, power can be added. So j plus t power 4 into k. This is what f vector. So first we have to write down r vector, then find out dr by dt, then consider f vector. Then we have to write down f vector dot dr by dt. Okay, got the point here? Okay, dot product is formatted. How to get the dot product? Leave I and I, j and j, k and k, just multiply the component. 1 into t cube. Look at that. 1 into t cube is t cube. That is what? T cube. And the next one is what? 2t into t power 5. You can write 2t into t power 5 plus. Next coefficient is 3t square into here what? T power 4. What you will get? T cube plus 2 into t power 4 plus 3 into t power 6. You can rearrange this from the higher order. 3t power 6 plus 2t power 4 plus what? T cube. So this is what? F vector dot dr by dt. But we have to find out integral in a curve f dot dr by dt. Therefore, we have the formula. So f vector dot dr vector is equal to integral from a to b. What that? F vector dot dr by dt into dt. Here where a is the lower limit and b is the upper limit. Here they are given that t is varies from -1 to 1. That is the limit here. Integral from -1 to 1 f dot dr by dt. We have already got this. 3t power 6 plus 2t power 4 plus t cube. This is f dot dr by dt into what? dt. So now it depends upon t. Now we have to integrate. 3 into t power 6 is t power 7 divided by 7 plus 2 into t power 4, that is t power 5 divided by 5 plus t cube is t power 4 divided by 4. So between -1 to +1. So after applying the upper limit and the lower limit, the final answer we got is integral of curve f dot dr vector. Ultimately, what will be the answer here? The answer become what? Okay, t cube into I. So t power 5 somewhere we got mistaken here. Okay, look at it. Look here. T into t square t cube. Okay, t cube by t power 5j t power 4k, right? So we have to multiply. So dr by dt 1 into t cube. Okay. That is the next is what here? 2t into t power 5. That is 2t into t power 5. This is not t power 3. That is t power 5. That become 2 power 6. Okay, now we have to make something here. So this become 3t power 6 plus 3t power 6 is 5t power 6 plus t power 3 only. Okay, instead of that I am going to write here. Sorry. Okay, that is 5t power 6 plus 3t power, sorry, only this is what t power 3. So after integration what we will get? This is 5t power 7 divided by 7 plus t cube is t power 4 divided by 4 between -1 to +1. So after applying upper limit and a lower limit, you will get the answer is 10 by 7. This is the procedure, right? We'll do one more problem related to the same content here. Okay. Have a look on this. Okay, the same thing will happen here. But between 0 to 1, what happens here? Between 0 to 1. Okay, I will do once again the same problem. Same problem. Okay, what is the procedure here? First we have to write the vector equation, right? What is the vector equation here? The vector equation r vector is equal to, okay, have a look on this. Let r vector is equal to, what is r vector here? Xi plus yj plus zk only. Now replace the value of x, y, z. What is x they are given? X is t, y is t square, z is t cube. That is equal to t into I, t square into j plus t cube into k. This is what r vector. Now immediately find out what dr by dt is it not? So that is equal to differentiate 1 into I plus 2t into j. T cube is what? 3t square into k. This is over. Now consider the force function, force field or a vector function. So f vector, what is f vector is xy into I, look there, yz into j plus zx into k. Now just very simple, we have the value of x, y, z. Just substitute here. What is x here? X is t, y is t square into I plus y is what? T square, z is what? T cube into j plus z is what? T cube, x is what? T into k. Simplify this, t cube I plus t power 5j, right? Plus t power 4 into k. This is what? F. After having this, we have to find out what? F vector dot dr by dt. Is it not? Okay. Now f is here. Sorry, f is here. Okay. And dr by dt is here. The dot product of these two is given by, so I dot I is 1, j dot j is 1 and k dot k is 1. Just multiply the component. 1 into t cube is t cube. Am I right here? 2t into t power 5, that is 2. T into t power 5 is t power 6 plus 3t square into t power 4. 3 into t square into t power 4 is t power 6. Simplify this. 3t power 6, sorry, 2t power 6 plus 3t power 6 is 5t power 6 plus what remaining is t cube. This is the f vector dot dr by dt. This f vector dot dr by dt is totally a scalar function where t be the parameter. There is no ijk here. When there is absent of ijk, that quantity become a scalar. When there is a presence of ijk, look here, here we have ijk, here we have ijk. Therefore, they are the vectors. When their dot product become a scalar. So now we wish to find out integral over c f vector dot dr. So as you know that the formula is integral from a to b f vector dot dr by dt into t into dt. Okay. Now we have to search for the lower limit and upper limit. They are given that the value of t varies from 0 to 1. So that 0 is a lower limit and 1 is the upper limit. So we can write integral from 0 to 1 f dot dr by dt. F dot dr by dt is what? 5t power 6 plus t power 3 into dt. Now you have to integrate that. 5 into t power 6 is t power 7 divided by 7. How it is? The integral of x power n is x power n plus 1 divided by n plus 1. One power goes increasing and the same increasing is divided in the denominator. Plus t cube is a t power 4 divided by 4 from 0 to 1. Am I right? So now after applying the upper limit and lower limit, for example, nodi, whenever you get lower limit is 0, don't give the value there. It is automatically vanishes. Just give the upper limit. When t is equal to 1, this becomes 5 by 7 plus 1 by 4. So 28 is the LCM. 7 4s are cross multiply. 20 plus 7. That is what? 27 divided by 28. So this is the line integral over C f vector dot dr. Got my point? Right? Let us consider few more problems. Right? Thank you.